Hello everybody, we're getting ready to do lesson 9.2 part 1, pre-calculus math. My email is animatedpowerpointmathvideo at AOL.com. So today we got 14 points that will go into your notebook guide or your notebook, and we will have 36 points that will go onto your classwork sheet for 9.2 ellipses part 1. Students, put your name, date, period in my classroom. If you're online or if you're a homeschooler, put your due date here. And then today's bell work, everybody. Today's bell work is determine whether the sequence is arithmetic, geometric, or neither. So here's our sequence here. Here's our sequence down here. Determine whether they're arithmetic, geometric, or neither. Teachers, give your students about 3 minutes, okay? Check back in 3, pause your video for 3 minutes. Okay, welcome back for the solutions for today's bell work. 66, 55, 44, 33, 22. Is that arithmetic, geometric, or neither? So it is arithmetic because we have a difference here of -11 as we proceed into the sequence. And then for 76, it's geometric. We have a common ratio here of 0.5. So 0.5 of everything will continue to decrease. And now on to our first slide here into our notebook. Students, have your notebook out. Introduction. The third type of conic is called an ellipse. It is defined as follows. The definition of an ellipse is a set of all points x, y in a plane, the sum of whose distances from two distinct fixed points or foci is constant. So here is a diagram here of two foci here on an ellipse. This distance here, d1 plus d2, is a constant. The line through the foci intersects the ellipse at 2 points called vertices. The line through the foci. The chord joining the vertices is the major axis, and its midpoint is the center of the ellipse. The chord perpendicular to the major axis at the center is the minor axis. You can visualize the definition of an ellipse by imagining two thumbtacks placed at the foci as shown. So here's your thumbtack here, here's your tack, here's your tack here, then here is your string that goes through that is anchored at each foci and is being run around here by the tip of a pencil. If the ends of a fixed length of string are fastened, here's your fixed end here, are fastened to the thumbtacks and the string is drawn taut with a pencil here, then the path traced by the pencil will be an ellipse. So as you run your pencil around like this is what you'll come up with this kind of dynamic here. Okay, so what does that have to do with us, rough? To derive the standard form of the equation of an ellipse, consider the ellipse of the following points. So here's an ellipse here. The center would be HK. So here's our ellipse here. We have a bunch of different identifications here. We'll start with the center, which is HK. And then our vertices are h plus or minus ak. So here is our hk. So we move this way for a and then this way for a. So here's our a here, negative a, positive a. And we come up with our vertices. And then we have foci, which is h plus ck. So here is our this is our negative c, and then this will be our positive c here. And see how we're forming triangles. We're forming a right triangle here. And then this is how we get our hypotenuse. The length of our hypotenuse, our calculation for that is right here. Note that the center is the midpoint. Yeah, we got that. of the segment joining the foci. Okay, so note that the center is the midpoint of the segment joining the foci. Here's our foci here, foci, foci, and then the center of that is your center of your ellipse. The sum of the distances from any point on the ellipse to the two foci is constant. So again, we go back to the constant, to the pencil thing, where we have D1, D2, and as you move around the ellipse, those two dimensions remain constant when you add D1, D2. Okay. Using a vertex point, this constant sum is A plus C plus A minus C equals 2A. So the length of a major axis here would be 2A. 2 times A here will be the length of this major axis. And this vertex, or rather this ellipse right here, this is your major axis, and it's 2A right here, 2 times A. Or simply the length of the major axis. So here's your major axis here. So they go through a line that goes through the two foci. Okay, that sounds good. Now, if you let xy be any point on the ellipse, then the sum of the distances between xy and the two foci must also be 2a. That is, so we have this expression here. We take the radical of each one of these distances here, of our foci distances, and they come out to be 2a, which after expanding and regrouping reduces to this here. So we have this gnarly expression here, which equals 2a again. Finally, you can see that b squared. So from all of this here, we can deduce that b squared equals a squared minus c squared, which implies that the equation of the ellipse is b squared times x minus h squared plus a squared minus y minus k squared equals a squared b squared. Say, wow, Ruff. This is almost like a proof that is proving the equation of an ellipse. Okay, that's cool. So again, we go back to this, x minus h squared over a squared plus y minus k squared over b squared equals 1. You would obtain a similar equation in the derivation by starting with a vertical major axis. So both results are summarized as follows. Standard equation of an ellipse will be the standard form of the equation of an ellipse with center hk and major and minor axes of lengths 2a and 2b respectively, where 0 is less than b is less than a, is, here it is, major axis is horizontal. In this case here, a squared would be in the denominator of x, so that would make it a horizontal. Our x-axis is horizontal. And then our minor axis here, b squared, would be underneath the y minus k quantity squared. That would be your minor there. And then major axis is vertical. We go back to that. So major axis now will be vertical. So major axis here. So a squared will be our largest denominator underneath our y minus k quantity squared. That would mean that your ellipse is more, it would be more vertically oriented when you have your a squared underneath your y minus k quantity squared. The foci lie on the major axes, c units from the center, with c squared equals a squared minus b squared. C units from the center, that would be where your foci would lie. If the center is at the origin, 0, 0, then the equation takes one of the following forms. So x squared over a squared plus y squared over b squared would equal 1. This would be your major axis is horizontal, because our a squared would be underneath our x squared, which means that our larger axes of our ellipse would be horizontal because it's underneath the x. And then here our major axes, now our a squared is underneath the y squared, so now your ellipse would be more of a vertically oriented ellipse because your a squared would be underneath your y squared here. Okay, so the vertical and horizontal orientations for an ellipse. So here we are here. So we have this ellipse here, HK, and then this, see how this one here is more vertically oriented, where your major axis is vertical. This major axis would be more horizontal, 2A, and then your 2A would be here. It would be along this vertical line there. So major axis is horizontal, and that would be your equation for that ellipse here, x minus h squared over a squared plus y minus k quantity squared over b squared equals 1. And then in this case here, your major axis is vertical, and then this would be the form for that. So your a squared would be underneath your y minus k quantity squared, and then your x minus h squared, b squared would be your minor axis, which would be here. Cool, right? Well, let's get into an example to perform some of this. Finding the standard equation of an ellipse. Find the standard form of the equation of the ellipse having foci at 0, 1 and 4, 1. So let's see, 0, 1 would be here, and then 4, 1 would be over here. So now this is our ellipse, and it looks to me like it has a major axis that's horizontal. I mean, you can tell just by looking at it, right? So, and the major axis of length of 6 is shown. So our major axis would be here, and it has a length of 6 here. Okay, so what are we supposed to do? Find the standard equation of this ellipse right here. By the midpoint formula, the center of the ellipse is 2, 1. So here is our center of this major axis here would be 2, 1, using the midpoint formula here. So we have a foci here at 4, 1, and then we have another foci here at 0, 1. Foci is c equals 2, so c would equal 2, which would be here. And then, so our foci would be, here is our foci here, 2 here, and then 2 over here. So we have plus or minus 2 from our center, which is 2, 1. So we go to the right 2 and to the left 2. So that would give us our foci. Because 2a equals 6, 2a in this case equals 6, you know that a equals 3. So this would be our 3 here would be an a, would be 3. And then this goes back this way for 3 as well. Okay, so far so good. So now from c squared equals a squared minus b squared, you have, plug in our values. B, in this case here, b would equal a squared, radical a squared minus c squared would equal 9 minus 4. Radical 9 minus 4 would equal square root of 5, would be our b. So because the major axis in this case again is horizontal, the standard equation would be x minus 2 quantity squared over 3 squared, because we do have a horizontal major axis here, and then our 3 squared here is definitely larger than square root of 5 squared. And then our y would be y minus 1 quantity squared over radical 5 quantity squared would equal 1. So this would be our minor axis would be here for that. And that's what they're saying here. So they're saying here that b would be radical 5. Okay, now that we know that, find the standard form of the equation of the ellipse with the given characteristics. So we have a foci here of 0, 0 and 0, 8. The major axis of length is 36. So knowing that situation there, what do we do with it? So knowing that, we can go our center in this case here, major axis length 36, foci 0, 0 and 0, 8. So we know that the center would be half of this, would be 0, 4, so h would be 0 and k would equal 4. Our c in this case would be 4. A would be 18, which would be the half of the length of the major axes. So we could plug in now to find b squared equals a squared minus c squared, would equal 324 minus 16 would equal 308. So the vertical major axes will be x squared over 308 plus quantity y minus 4 squared over 324 would equal 1. And that would be our standard form of the equation of the ellipse with these given characteristics. And then students, I want you to do this one on your own. But I do throw that in. It must be Friday or something. So here's your center here at 2, -1. So we get an h here of 2. And then our k here would be -1. And then our vertex would be 2, 1/2. Will be a would equal 3 over 2. So we go 3 over 2 in both directions here. And then our minor axis length would be 2 would go to b would equal 1 in this situation here. So 1/2 of 2 would be 1. Okay, moving right along. Do I do this one for you too? Is it really Friday? It is really Friday. So going into our standard form, we plug in our values here of h and k. We have -2 and then +1 over 1. So our major axes here would be the ellipse would be oriented in a vertical manner. So that would be the way that it's oriented here. Our major axes would be a vertical axis. So this would be x minus 2 quantity squared plus 4 times y plus 1 squared over 9. So we multiply through by 4 here to get rid of this. We square this, which would be 9 over 4. And then we multiply through by 4, and we simplify this to this quantity here for this second term of that equation. Okay, so moving on to another example here, sketching an ellipse. So sketch the ellipse given by 4x squared plus y squared equals 36, and identify the center and the vertices. Okay. So 4x squared plus y squared equals 36, write original equation. And then divide each side by 36. We want to make this equal to 1. So when we do that, we have this form here. And then we end up with this here, x squared over 3 squared and y squared over 6 squared. So once we have that, we can kind of tell what the ellipse is going to be oriented by this 6 squared here. So the center of the ellipse is 0, 0. Because the denominator of the y squared term is larger than the denominator of the x squared, you can conclude that the major axis will be vertical. Moreover, because a equals 6, the vertices are 0, -6, and 0, 6. And then finally, because b equals 3, which is 1/2 of a, the endpoints of the minor axis would be -3, 0, and then 3, 0 is shown. So this would be your actual ellipse here given by this expression here. So we have it's vertically oriented, and then here are your vertices there, and then here is your major axes, here's your minor axes, -3, 0, and then 3, 0 out here. So there is your sketch of this expression there. Okay, cool. So what about that? Graphical solution. So if we're just going to use a graphing calculator to graph that thing, which would be a lot easier. Here's our original here. We solve for y. So we get y equals plus or minus radical 36 minus 4x squared. And then we're going to use a graphing calculator to graph it. So y1 would be positive radical 36 minus 4x squared, which would be this part of the ellipse. And then the other part of the ellipse will be the negative part, negative radical 36 minus 4x squared. That would be the bottom part of it. So that would be how you would graph it on a graphing calculator in the same viewing window. So this would be it. This would be how your graph should show up. Okay, let's try one now. So we have our guided practice here. A, find the standard form of the equation of the ellipse. B, down here, we're going to put the standard form here. And then B, find the center, vertices, foci, and eccentricity of the ellipse. We're going to put that down here in B. and then C, which is on your next page, sketch the ellipse. Okay, so for our part A here, what did we do with part A? So here's our original x squared plus 9y squared equals 36. And then we're going to get rid of this 36, make it 1. So we're going to divide through by 36, which is cool. Here's your equation here for the standard form of this ellipse. And then B would be find the center, vertices, foci, and eccentricity. So we have A here equals 6, B equals 2, and then C would equal radical 36 minus 4 would equal radical 32, which equal 4 times square root of 2. So we have a center here at 0, 0. We have vertices of plus or minus 6 because of this here. And then our foci would be plus or minus 4 times the square root of 2, and then 0. So on your this one here is horizontally. It is horizontally oriented ellipse. And then our foci, we have a center here at 0. So our foci would be plus or minus 4 times square root of 2, and then 0 on your ellipse. So it would almost be a good idea to graph this thing on your graphing calculator to get a visual on that. And then for C, for our eccentricity here, C, or rather E, would equal C over A, and then we do that quotient, we come up with 2 times square root of 2 over 3 for our eccentricity for this ellipse here. And then up here, do I actually graph that thing? I might. No, I leave that up. No, I guess I do. Here comes your graph. This would be the graph of that ellipse right here, students. So take note of that. That's what you should have on your graphing calculator. And that is your 9.2 part 1 pre-calculus math classwork. And here's my email, questions, course materials, animatedpowerpointmathvideo@AOL.com. Thank you very much.